Okay, g'day everyone. Welcome to part 3 of Containers in Azure with the great Yas. And Yas, again, as we said in the earlier video, is going to cover off AKS, Azure Arc and AKS Engine. So Yas, back over to you, mate.
Thank you so much, George. We talked about quite a few different ways to run your container workload within Azure, and it's really time to go into a bit more advanced situations. And for the advanced situations, I think it's simply time to go through Azure Kubernetes Services, or AKS for short. When you try to run more than a few containers within your environment, and if these containers have complex requirements, let's say you need to simply lock down a particular container, you need to enable some sort of a auto scaling for your containers, you need to manage the runtime of those containers in a centralized manner, you need to, or quite a few different type of features that are offered by AKS. You simply need to go and have a look at this amazing service. What AKS provides for you is that it creates a cluster of nodes, and these nodes, you can think of these nodes as VMs that are powering the containers in your infrastructure. So let's say you have your container registry, this is your AKS instance, and you're storing a bunch of images within your AKS instance using a CI/CD pipeline, or however you might be deploying those images into that particular container registry. You can leverage your CI/CD pipeline to deploy those into your AKS. However, for that, within your pipeline, you can leverage, for example, Azure Policy, and Azure Policy allows you to verify the compliance of those images. As I mentioned before, especially if you're using a public image repository such as Docker Hub, these publishers might not be well known, or there might be people coming from all different backgrounds, or either wanted or unwanted. They could introduce some sort of vulnerability in those Docker images. For that, you can definitely do a compliance check in Azure using Azure Policy, and if the compliance check passes, you can then deploy those into your AKS workloads. So again, one of the advantages of using AKS compared to the other traditional ways of running the containers, apart from the orchestration, is the ability to run it within your CI/CD pipeline and deploy those images in a secure and reliable way. Azure Container Registry Kubernetes Services is at the moment deployable into more than 42 regions and counting. You can run your various operating systems such as Linux and Windows containers within this amazing service, depending on what type of pricing tier you're choosing and what type of environment you're trying to run the AKS on. And you can sort of deploy and leverage multiple different environments. So this AKS can be run on your public cloud using for example, using Azure. You could run it on your own premises using the AKS Engine that we're going to cover shortly, and on the IoT edge as well using the AKS Engine again, which we're going to cover in our next section. So Azure Kubernetes Services is a really great service which allows you to deploy your services within multiple parts of the world, leverage the great amount of orchestration which is offloaded from you as a developer or as a operations team to manage all of that, and that is all handled by the Azure. Some of the use cases for the AKS is sort of lift and shift your containers with AKS. So if you have already running containers within your environment and they're getting out of hand, let's say you're having a container for your SQL Server and a MongoDB and a web app and I don't know, a whole heaps of different types of web applications running, whether they're internal or external, you could sort of manage all of those, bring them into AKS and manage them centrally so that you don't need to worry about, for example, operating system patches, or you don't need to worry about security vulnerabilities in the images, or you don't need to worry about how they are getting auto-scaled, or how the workload is handled between different containers, or simply if you wanted to load balance your workload between multiple containers of different sorts. You could definitely leverage AKS for those scenarios. As I mentioned before, you can simplify configuration and management of microservices based applications. So if you have multiple different microservices that need to be run in a unified environment, and you need to make sure that they are secure, they are protected, they are compliant with your security requirements, and so on and so forth, AKS does that automatically for you. You will basically are bringing DevOps and Kubernetes together when you're using AKS, because at the same time as this is a managed service, it allows you to deploy your containers really easy using your CI/CD pipeline of choice, whether it's GitHub Actions, whether it's Azure DevOps. All of those are already supporting your AKS deployments, and it's really easy. The other factor is that the deployments into AKS, and we're going to see that in the demo shortly, can be done through scripting languages and CLI, such as Azure CLI and Azure PowerShell. And for that matter, it also goes beyond just those tooling. So regardless of what deployment tool or what CI/CD pipeline you're using, you can definitely leverage and deploy your containers really easy with this amazing technology. Ease of scaling. Azure Kubernetes Service does come with a built-in auto-scaler that will expand your number of nodes and the pods that are running within those nodes. If you're not familiar with these concepts, don't worry about it. It's just different ways of saying a VM and a bunch of processes that can run containers within that VM. So if this is your node, these are your pods. And inside this pod, you can have multiple containers running. So really, not complex topic. It's just a different terminology that when you're using AKS for that matter. So Azure Kubernetes Service automatically scales out your node based on the workload that is at the moment is on those particular nodes, and then adds more pods to those nodes. And if the capacity reaches its limit, it will add a new node and new node and new node. And you can also enable a concept of virtual nodes. With the concept of virtual nodes, you can leverage the power of Azure container instances to be playing the role of backup for your AKS cluster, just in case the AKS cluster workload cannot go beyond that particular number of nodes that is already reached. So in short, if you are running a mission critical workload, AKS might be a great option for you based on these number of different features that are existing for you. Data streaming is really something that AKS can handle really easy for you because it has the concept of the load balancer. It could leverage that to sort of stream your information inside your AKS cluster, and you can then, it will be distributed between those nodes and pods and so on and so forth. So these are a few use cases for AKS. Let's jump into a demo. We're going to run the Azure voting app within AKS and see what it takes to run this workload within the AKS. So first of all, similar to other demos that we had, we need our Visual Studio Code or any particular editor that you might have handy. A bunch of commands, Azure CLI commands, which you're going to review. But before we review the commands, let's review the resource file. This is the resource file that we want to deploy within our AKS cluster. A resource file is in YAML format. YAML is something which is keeps your text as indented items. So it's really easy to be messed up if you get the indenting wrong. So a lot of people out there in the community are not really a fan of YAML. They might prefer JSON, but at this point, we're going to use YAML to create and deploy our resources within Kubernetes. So basically, you don't need to be familiar with the syntax or what is going on here. I'm just trying to say that you have two containers that we're going to run within this particular application. So the application structure at the moment has a front-end node and a back-end node. If I wanted to quickly do a bit of a whiteboarding here, this is your web app. This is a voting app that has or is leveraging a back-end database, and this database is simply a Redis cache container. So when you vote for a particular animal, this is persisted into this database, and next time you're going to see the votes, it will get that information back from the database and show it to you. So you have one container to run the web app and another container to run the Redis database. So here you can see we have our Redis, and this Redis comes with a bunch of requirements. So it's got 100 megabyte of CPU and 128 megabyte of memory and so on and so forth. And it exposes port 6379. So this is our backend service. For that, we are saying that, hey, this particular container runs within the service. This is the port that it should be exposed. And then we have another service. This is our front end. This comes from another image. So this is our Azure, which is coming from our Docker Hub image container. And this has a dependency on the Redis backend. So it's got an environment variable and it's got the service reference for that particular Redis because it tries to talk to that. This container is exposing port 80. So when this container is running, this would be our front-end container. So we have this resource file. This resource file is going to tell Kubernetes to what to run in our cluster. Now, similar to what we saw before, we have our resource group and we have our location. So once we define these variables, we're going to create our resource group. This is already done, so it's going to be super quick here for us. Next thing is create or deploy your AKS cluster. So with the AKS cluster, you basically tell it, hey, this is my resource group, deploy it into there. This is the name of the cluster. Always make sure that you choose meaningful names and you have a consistent naming convention for all your Azure resources, not just these ones. We are telling that, hey, this AKS only has one node because there is not a critical workload, so we are not going to go past that. We're going to enable the monitoring for our nodes and generate SSH keys once these nodes are generated so that we can use those SSH keys to talk to our nodes if it needs to be, or talk to our containers. Creating a Kubernetes cluster might take a while, so I've already done that, so I'm not going to run that command anymore. Once you have that, you can use the AKS get credentials or AZ AKS get credentials to authenticate to this particular instance of AKS. When you authenticate, it will merge the authentication context with your local terminal, and from there on, you basically can run your kube controller commands. If you don't have kube controller commands, all you need to do is run the AZ, let me just go, AZ AKS install CLI, and this will install the CLI of that particular AKS for you, and you have access to the kube controller commands locally. So next thing we want to do is running our get nodes command. This will tell us how many nodes do we have. We already know we deployed one node, so it will bring up that one node. It will tell me, hey, this node is in a ready state, it's running, it's healthy. Next thing is we want to deploy our resources into AKS. So for that, you just simply say kube controller apply -f for force and pass that particular resource file. So this is our AKS resource file. It will deploy those deployments and services that we had within that file. And this is already done. So if you run the watch command, it will tell you that, hey, this is already running. It tells you that Azure Frontend already has a type of load balancer. This means that this is a publicly available application. It tells you what is the local IP address. So this is the invalid IP address, and this is the external IP address. So this is a public IP address. It sort of shows you the port mapping. So this can be accessed through this particular IP address. So if I bring up my browser and come into this IP address, you can see the application already is up and running. I can vote for cats or dogs. I can reset and do a whole bunch of stuff. And if I close this, open up a new browser window and come back, those states are maintained simply because it's using that Redis cache database behind the scene to persist the information that we have within our cluster. So really great way for you to manage your nodes within your AKS cluster, run multiple containers, manage all of those centrally, and a whole bunch of different stuff. I wanted to show you the AKS as well in the Azure Portal to sort of highlight some of the features that come with AKS.
So, Yas, I've got a fun fact for you, mate.
Sure.
Fun fact. That particular demo there, the cats versus dogs, was created by my good mate Neil Peterson, and he did it a number of years ago when containers was the new thing. And he did it when he was part of the content writing team because he was a technical. He's in the Azure Tools team now or something like that, and it is just never stopped being. It was one like the first demo that people ever used, and still to this day is the demo that people use for AKS. So it just shows you the longevity of stuff inside from a containers perspective. It's quite interesting.
Yeah, thanks for pointing that out. It's a really great way to get up and running, and simply because the complexity of the deployment is not really that much. So people, if people come from a non-developer background, is still a chance that they understand what's going on and what they're deploying within this particular AKS cluster. So within the AKS cluster, you have a bunch of resources. So you have your namespaces, you have your, for example, workloads that are running at the moment. These are the workloads that we deployed, and these are the default kube system workloads. You have your services. So these services that we deployed, it's exposed through an external IP address. It's got an internal IP address as well, and this one as well. This is a cluster IP, so it only has an internal IP address. So that means that you can never reach this Azure World backend from outside of the cluster. You can definitely add storage, persistent storage for your containers and access that centrally. So if you wanted to, for example, create a persistent sort of volume for your storage account and share them between your containers, definitely you can do that. And you can see the configuration of all of these the resources that you've deployed and what can you, for example, configure within all of these config maps or secrets. So these are configurations that are accessible as an environment variable within your containers. You can also add secrets, and at the moment you can see that all these different secrets that are being deployed within our cluster. You can have a look at the node pool. So at the moment we only have one. You can have a look at the scaling and enable the scaling for this particular, based on the pricing tier of the AKS. You might see different type of, for example, scaling rules for these node pools. I think that's been deprecated. You can leverage the scaling rules on the node pool itself. You can see that the maximum nodes pods per node is 110, and at the moment the node count is 1. So you can enable the scaling based on auto scaling and say, hey, this is my range and whatnot, and everything else is managed by AKS. You have your networking infrastructure if you wanted to. So AKS gets deployed within a virtual network. So you already are using a virtual network. If you wanted to enable traffic between this virtual network and other virtual network, you can definitely do that. And you need to just enable the routing, the necessary routing to be able to route traffic within these different VNets. There is also a deployment center in preview, which you can leverage, such as creating a mini CI/CD pipeline for really complex situations. We don't recommend to go through the deployment center here. You definitely need to go through your choice of, for example, your CI/CD pipeline, whether it's Azure repos and GitHub, or if you wanted to go based on external Git. If you have a complex deployment, go from that side, not come from here, because there are limited capacity when it comes to defining those from here. You also have policies. If you wanted to onboard or enable onboarding policies that I mentioned earlier, using these policies, you can definitely try to put a security gate on top of what images can be deployed through this cluster and so on and so forth. Here are your monitoring services, integration with Azure Monitor. You have your metrics and insights and logs and everything else that you can see for your AKS cluster. So really, really great service when it comes to running multiple containers centrally, manage them, and handle the workload regardless of how big it is. The next service we're going to cover is Azure Arc. Azure Arc is not a service per se. It is a platform or a capability which allows you to run your workloads or manage your workloads from multiple different points. So when you're using Azure Arc, you basically are using a sort of a management layer which allows you to manage nodes or workloads within multiple different type of environments. So you have your, for example, Edge. If you're running Azure IoT Hub, or if you're running Azure Stack Edge on a Edge server, whatever it might be, you can definitely manage it through the Azure Arc. You could also manage your on-premises environment, whether it's on an Azure Stack Hub or any hardware that you might have on premises. You could definitely leverage the workloads using the Azure Arc as well. And you also, it allows you to do multi-cloud as well. So as I said before, it's not a single service, it's a management, it's a suite of management tools which allow you to manage your workload. And for that, Azure Arc allows you to manage your container workloads in those environments that it's supporting as well. So what are the use cases of Azure Arc? When can we leverage or should leverage Azure Arc compared to other services that we have talked about? If you are managing multiple sites, let's say you have your Kubernetes running in your on-premises, but you have a requirement as a customer to go multi-cloud. So you're running a Kubernetes instance in your on-premises, and you're running a Kubernetes cluster on your Azure and on AWS or on GCP. For that, you could leverage Azure Arc to manage all of that centrally. So you don't need to go and manage individual components one by one based on the different cloud providers. So really great for you to centrally manage all of those nodes and pods and everything else for you. If you want consistent deployment and configurations with Azure Arc, you can deploy your containers globally on all of those different platforms that we have specified. So on your edge, on your on-premises, on your multi-cloud setup, you can deploy your containers within those and manage those centrally. Again, a great way for you to leverage this service, and instead of going and manually try to sort of have different type of configurations for different platforms, you can manage all of that using the Azure Arc. Or if you have regulatory requirements, if you, for example, if you live in Europe and you have some sort of a legal requirements that the information should be maintained within the same region or whatever it might be, Azure Arc can be helping you to apply those requirements globally within all your infrastructure, not just a single platform. So really great sort of use cases for using Azure Arc to manage your Kubernetes or container workloads. And the last service that we want to talk about is Azure AKS Engine. So previously, George asked me, hey, Yas, can you run a Kubernetes workload, AKS workload within your service fabric? And I said yes. And the reason why I said yes is because of this amazing service. Azure AKS Engine is the engine which is powering our AKS. So we have open sourced it, and we have let people to leverage this engine and run them if they feel like they can use our service on the cloud and they want to run the same set of services and leverage the same set of features, but on their on-premises or on a different cloud provider or on Edge or whatever it might be. So you can leverage those and leverage the service, deploy it in your on-premises, on your physical servers or virtual servers or whatever it might be, and leverage the same set of features that we have on offer when it comes to Azure AKS. Of course, there are some features that are not available when it comes to using the engine compared to the AKS cluster in Azure, and simply because some of the integrations with other services within the AKS cluster or some of the features that are there, they're cloud specific, so they're very specific to Azure. So you won't get to choose and use those. However, for the majority of different features, you could definitely leverage the AKS engine. So here is a diagram which shows you, hey, you can definitely leverage two different Kubernetes cluster on your on-premises environment. Let's say one of them is running on a Azure Stack, and the other one is running on a set of virtual servers on your on-premises. And you definitely can leverage the Azure Kubernetes engine, deploy those, manage those, because they offer the same set of APIs that Azure Kubernetes Cluster or AKS offers. So you can have, for example, a network traffic manager to manage the workload between those nodes on your on-premises or on a different cloud provider, and then use the same sort of APIs to do automatic deployment, to do updating your AKS cluster, or enable auto-scaling, or a whole bunch of different stuff that is available based on that service. So what are the use cases? When can we use this service compared to AKS itself? If you need AKS's features, but need to run these containers outside of Azure, this is a great service. You can leverage it. If you manage Kubernetes clusters on Azure Stack Hub, definitely use this service instead of trying to reinvent the wheel and set up everything from scratch. This is a sort of considered as a recipe which is pre-made for you. You just deploy it and everything is already done for you, whether it's security requirements and configuration, whether it's enabling or exposing ports or closing ports or enabling load balancing and a whole bunch of different stuff. So these are all the different ways that you can run your container workloads in Azure. I hope you've enjoyed these multi-episodes, and it's been a really pleasure to run everybody through all of these amazing services.
Thank you, Yas. Really appreciate that. So thanks for your time. Thanks for all those who've watched. Thanks again, Yas, and see you, everyone.
Thank you, and have a great time, everybody.